Welcome to lesson 18 of GMAT Math Basics. Today, we're going to talk about PEMDAS, which is also known as the order of operations. Now that we've covered basic operations and some of the advanced versions of them, such as exponents and roots, we'll start to put all those elements together into more complex expressions. When you're dealing with more complex expressions in math, there's an agreed upon order that makes sure everyone's math can be read by everyone else. It's kind of like a common language. The core of that language is typically called PEMDAS, PEMDAS, which is a way of describing the order in which certain operations should be done. There's other names for it other than PEMDAS, and they all work. So if you learned them a different way as a young person, or if you need to relearn them now, then you can go back to those familiar patterns, or you can learn it the PEMDAS way, which is what I'm going to teach. The only time that I would recommend changing the way that you have used it in the past is if your current system or your past system is no longer working for you. But if it's working, let's judge it by the results. Before we jump in, here's a quick quiz that's going to cover what we're going to talk about today. And this can also serve as a nice way to test yourself on this information as time goes on. There's a quiz like this at the beginning of every single lesson of this GMAT Math Basics series. Question number one, what does quote unquote order of operations mean? Question two, what does PEMDAS stand for? Question three, how do you deal with many addition and subtraction steps when those are happening sequentially or in a row? Question four, how do you deal with many multiplication and division steps when they're happening sequentially or in a row? Question five, how do you deal with negative signs inside versus outside parentheses? And finally, what does it mean to distribute a term? Here we go. Question one, what does order of operations mean? Order of operations means when there are many operations to do. And by operations, I mean multiplication, division, addition, subtraction, exponents, things like that. When there are many operations to do, in what order should they be done? This becomes clear with a couple examples. So let's jump right into one. Let's say we've got the example of 6 plus 3 times 5. 6 plus 3 times 5. There are a couple ways that we could do these operations. I think what's most logical for most people is to simply go from left to right. But if we did that, we would end up doing 6 plus 3 first, which would yield 9. And then we would multiply the result of that times 5, which would give us 45. So 6 plus 3 times 5 would give us 6 plus 3, which is 9. We multiply 9 times 5, we get 45 as the result. But that is totally incorrect. That is not right at all. So we actually need to multiply 3 times 5 first. We need to multiply 3 times 5 first, even though we're not just going from left to right in a sort of naturally logical sequence, the way you would read words from left to right. It's not that simple. So we have to multiply 3 times 5 first to yield 15. And then after that, we add the 6 to make 21. Why does that matter? Well, let's just suspend the rules for a second and imagine that both of those situations are theoretically possible and that there's no agreed upon order of operations and that there isn't a rule out there that says you must multiply before you add. That could create a lot of confusion. Consider a real world example. Might make this make a little bit more sense. Let's say you're going to throw a party, like a wine tasting party, and you have 3 cases of wine, each with 5 bottles in the case. So that would mean like 15 total bottles of wine, 3 cases of wine, 5 bottles each. Your friend is also going to bring 6 bottles over that she has. If another friend texts you and says, "Hey, how many bottles of wine will we have at the party?" And then you text back 6 plus 3 times 5, and let's just pretend that you would actually text it that way for a second. And those people don't know PEMDAS, they don't know the order of operations. They might think that you have 45 bottles of wine, when in reality, you might have only 21. Now, at a party, that is probably not the end of the world. But what if the text exchange is about team members for a certain client on site? That's pivotal for your business, or the number of rounds of funding you'll need to fully capitalize your startup. Those are high stakes situations, and every number and every operation counts. So, why do we have order of operations? That's a good example. If we add before we multiply, then we're actually going to end up multiplying something that's too big, because we're not just adding 6 bottles of wine one time if we add the 6 to the 3 first. If we add the 6 to the 3 first, now we're multiplying 6 by 5 and also multiplying the 3 by 5. And that's why we got a number that was way bigger than the bottles that we actually had. Multiplying things is super powerful. There are times when you might want to add first and then multiply, and there are tools for making that happen, but you want to make sure that those tools are crystal clear to anyone who's trying to interpret your mathematical calculations. And that's why, in general, we have this agreed upon rule that we will multiply first and then add second, so that we're not multiplying every single item in a situation, or like over multiplying is how you could think about it in that example. So hopefully that's a reasonable illustration of why we care about the order of operations. If we don't have an agreed upon order to do mathematical operations, then we can wind up having grossly different results for the same set of calculations between people, which perhaps obviously creates a lot of friction, and that's not desirable. It's not a desirable situation at all. So that's why we have order of operations, and kind of like what the definition of order of operations is. That brings us to the question, though, naturally, what is the proper order of operations, and how do we remember to use that properly on an exam like the GMAT? Skipping over a lot of history here, to establish a universal order of operations about 500 years ago, some people started agreeing on how things should be done, and that's how we got PEMDAS. PEMDAS is what's called an acronym. And what that means is each letter represents a word in a sequence. So P stands for parentheses. E stands for exponents. M stands for multiplication. D stands for division. A stands for addition. And S at the end stands for subtraction. Again, there are other versions of this acronym, but the basics remain the same. That this is an agreed upon order that allows math from different parts of the world and different people to be interpreted universally, which hopefully I've demonstrated to at least a small degree is extremely, extremely helpful. So if we decide to obey PEMDAS, which is a very, very good idea if you want a great GMAT quant score, that means that anything that's inside of parentheses has to get calculated first. So the P in PEMDAS represents the very first set of operations that gets done when there's lots of math operations that could be done. You always start with parentheses. Then anything to an exponent, which is the E in PEMDAS, or a root. It's worth noting that exponents and roots are kind of on the same level with PEMDAS. Anything to an exponent gets calculated after you've already computed what's inside the parentheses. And only after you've done those operations can you multiply or divide. But you must multiply or divide before adding or subtracting. And that was the pivotal step that I was playing around with in our recent example. So that's what's called order of operations. PEMDAS is just a convenient way of remembering that order. Once again, anything inside the parentheses gets calculated first, then anything to an exponent or root gets calculated, and only after you've done those operations can you multiply or divide, and you must multiply or divide before adding and subtracting. Adding and subtracting come at the end. PEMDAS is really important on the GMAT. Okay, super, super important. I've said this before, I'm going to say it again because it's so important. Their job is often to test simple concepts in complicated ways. So they'll usually test really complex and scary looking things that ultimately come down to mastery of some very, very basic math concepts, which is why we're making this series for you in the first place. So let's consider an example that might show up on an actual exam. This is going to be a little bit complicated if you're on the audio feed. So imagine you've got a set of parentheses, and inside those parentheses, we've got x squared plus 3. And then up and to the right of the parentheses, outside the parentheses, you've got that whole quantity inside the parentheses squared as well. And then let's say we've got plus 3 right to the right of that. So don't worry if you're not following along with that perfectly, because even visually looking at it, it can be a little bit confusing at first to figure out, wait, what's being squared where, and what's the order in which I should do this? Like you might be tempted to just add 3 first because it seems convenient. That's why PEMDAS is so important, because that's not allowed. You're going to get the wrong value if you start adding before you do parentheses or before you do exponents. A question like this is really designed to measure a couple things. Number one, do you really know the order of operations? And I guess we could make the argument that you could also think about it as testing some broader skills, such as how good are you at preparing for really important things? Like if you know the GMAT's an important part of going to business school, then can you organize yourself and stay consistent to actually prepare and perform well in those kinds of situations? And arguably a host of other valuable skills, such as problem solving under pressure, all of which could theoretically be helpful as a business leader, which I guess is like a broad catch-all term for what most of us are chasing with an MBA in the first place. So I don't want to go like too macro with this. Let's stay focused on just like the core skills of like, okay, they're testing me on PEMDAS. Let's just keep it simple for the purposes of this discussion. And I also don't want to scare you, but like that's not even that bad, that example I gave you in terms of stuff that they could show you on the GMAT quant section. And things can get way more intense and way more complicated during the actual test. But hopefully what will help is understanding that ultimately a question like this just comes back to PEMDAS, which is what we're talking about right now. There are other skills involved in getting complex questions right, like this one consistently, but without PEMDAS, we are like almost certainly going to be wrong no matter what else we do well. So again, that's why we're starting with these basics. So I don't want to say PEMDAS is the only skill that you need to get a question like that right during the GMAT, but it's an absolutely crucial skill. And even if you're like great under pressure and you're great with your scratch work because you listened to the GMAT strategy podcast and hopefully you took my advice on that. And even if you're super good at solving complex problems, if you don't know PEMDAS, then it's probably not going to be a very good day on GMAT test day for the quant section. Okay, so this is necessary but not sufficient. But given that it is necessary, we want to build this up, and we will get to all the other skills down the line. And many of those we've actually already covered in past episodes, which I welcome you to listen to if you're new to the pod. So a couple examples for us to try out here just to get comfortable with this whole PEMDAS situation. And then we will talk about some of the nuances that are worth mentioning, given how important PEMDAS is on the test. First example, what's 3 plus 4 times 2? Take a moment and see if you can calculate that. If you're on the road or on the go, just visualize to the best of your ability in your mind 3 plus 4 times 2 with no parentheses anywhere. 3 plus 4 times 2. I'll give you a moment. You might be tempted to add 3 to 4 first because it's logical to do this like left to right type of operating. But that violates PEMDAS. Multiplication comes before addition and subtraction. And so the first correct operation to do here is 4 times 2, which equals 8. And then after you do that multiplication, you add 3 to make 11. So the correct answer to 3 plus 4 times 2 is 11. Let's do another example. What's 8 plus inside parentheses 6 divided by 2? Okay, so inside the parentheses, I've got 6 divided by 2 times 3. So 8 plus inside the parentheses 6 divided by 2 times 3. So we have to do what's in parentheses first. So we'll end up doing 6 divided by 2 first, which equals 3. Then we have to multiply before we can add. And so we will multiply 3 times 3, which gives us 9. And then the very last move is to add 8 to 9 to generate 17. So 8 plus 6 times 2 in parentheses, 8 plus in parentheses 6 divided by 2 times 3 is going to equal 17. Okay, one example going a little more complicated here. Let's say you've got a set of parentheses, and inside that set of parentheses is 1 plus 3 squared. So imagine a set of parentheses with 1 plus 3 squared inside of it. And then outside the parentheses, you're going to take that whole thing in the parentheses to the second power. You're going to square the result of what's in the parentheses. Take a moment and see if you can figure that out. 1 plus 3 squared inside the parentheses, and then that whole quantity squared. We do the parentheses first. But inside of the parentheses, we still obey order of operations. So if you have some addition and some exponents to do inside a set of parentheses, the exponents will still come first. So PEMDAS operates within a set of parentheses, just like it operates outside the set of parentheses. So don't add 1 plus 3 first and then square it. That's going to be too big. We do the exponent first. So 3 squared is 9. And then we add 1 to that to make 10. So now we're done with everything inside the parentheses. Then we've got that whole quantity to the second power. So we calculate 10, we square that, and the result is going to be 100. So 1 plus 3 squared, that whole quantity squared, is going to be 100. Those are the basics of order of operations. If you learn those well, you should be in good shape with the basics for this kind of stuff on exam day. I do want to set you up for some additional success and fast track your GMAT math basics progress a little bit. So let's discuss a couple notable additions to the core concepts here. First note, think about multiplication and division as being on the same level. So even though in the acronym PEMDAS, M comes before D, there's actually no hierarchy between multiplication and division. What does that mean? That means that multiplication doesn't have to happen before division, and division doesn't have to happen after multiplication. They just both have to happen after exponents, but before addition and subtraction. Hopefully, though, you're asking yourself, well, what if there's like a bunch of division and multiplication in a row? Something like 3 times 4 divided by 2 times 7. Like that, there's a couple different ways you could go about that. So let's make a rule for how to deal with that kind of situation. And I would recommend memorizing that within multiplication and division, always operate from left to right. So if the only operations that you have to do are multiplication and division, start with the operation that's furthest to the left and go left to right. So that's one situation where you can just kind of do it this logical way, the way you would read from left to right if you're reading in English. I'm sorry, I forgot that caveat earlier. Not every language reads from left to right. But if you're listening to this in English and you're taking the GMAT in English, which is highly likely, then that left to right sort of logical progression hopefully makes sense. But that's good news. Within multiplication and division, you just go from left to right all the time. So let's go back to this example I just gave of 3 times 4 divided by 2 times 7. So we can just start on the left with 3 times 4. So we do 3 times 4 first, which equals 12. And then we do the division, which is divide by 2. So 12 divided by 2 is 6. And then we do the final step, which is 6 times 7, which equals 42. So 3 times 4 divided by 2 times 7, with no parentheses anywhere, is going to equal 42. Why does that matter? Well, imagine if you did all the multiplication first and then did the division later, you'd actually get a different result. So for example, if we did the multiplication first, 3 times 4 on top would give us 12, and then we did 2 times 7, that would give us 14, and then we would have 12 divided by 14 because we saved the division for last. And perhaps obviously that's not the same as 42. So we would get a totally, totally different answer. And that's why those kinds of conventions are super, super valuable. They again, they allow us to speak a common language of numbers. Really, really valuable, really important, because it's really valuable and important to be able to share numerical concepts and calculations amongst people with different backgrounds or across different communication channels. I mean, just imagine what would happen in the world if there was no common system of numbers. Like it would be so much less efficient. There'd be so many things we could not do that really rely on this. So without going too far about with the why and like going too macro again, let's just stick with memorizing the rule within multiplication and division, always operate from left to right. Next valuable and additional concept, it's also very worth memorizing that the same thing applies within addition and subtraction. It works the same way. Within addition and subtraction, operate from left to right. So just to really drive this point home, addition and subtraction must happen either inside parentheses or after everything else. They're at the end of PEMDAS. But if you have 5 steps of addition and subtraction in a row, in those situations, just like with multiplication and division, you just go left to right. Let's use an example. What's 10 minus 3 plus 5? Think about it. 10 minus 3 plus 5. If you do 3 plus 5 first, and you started with the addition and saved the subtraction for the end, you would get 3 times 5 equals 8. And then you would do 10 minus 8, which would yield 2, but that's incorrect. Instead, we do the leftmost operation first, which is 10 minus 3. That gives us 7. And then we add 5 to that to get 12. All right, so the correct result of 10 minus 3 plus 5 is 12. That's multiplication, division, and addition, subtraction. In those situations, always go left to right. If you remember those things, you should be in great shape if those kinds of situations arise on test day, which they almost certainly will. That this is like virtually guaranteed you're going to see PEMDAS related stuff on your official GMAT. What else is worth discussing here? Let's talk a little bit about negative signs inside versus outside parentheses. It's very commonly tested, and it's also just an easy thing to get wrong, especially if you haven't had a lot of practice with this recently, which I assume most of you listening to this have not. It might have been a very, very long time since the future of your career depended on knowing how to do math without a calculator. Let's just be real. It's probably been a minute. So one of the best examples of testing simple concepts in complicated ways is negative signs with parentheses. Quick example of this. Let's say within a set of parentheses, inside the parentheses, you've got -3 plus 5. So the negative sign is inside the parentheses in front of the 3. If we're in that situation, we would add -3 to 5, which yields 2. But if all we did was move that negative sign outside the parentheses, and so it was a set of parentheses, and inside of that set of parentheses, you had 3 plus 5, and then outside the parentheses was a little negative sign, you would have to add the 3 plus 5 first, and then multiply that result, 8, by -1. And that's the way that I would recommend thinking about that if you have a negative sign outside a set of parentheses. Think about the negative sign outside the parentheses as multiplying by -1. It'll really help with sticking to PEMDAS because multiplication comes after parentheses. Now, if you don't need like a tool for remembering that and it's already intuitive for you, which it will be for a lot of you and won't be for a lot of you, that's totally fine. You don't have to change the way you're thinking about this if you're getting good results, like I said at the top of the lesson. But if it's been a while and you're like, wait a minute, how do negative signs and parentheses work again? Just remember that a negative sign outside the parentheses, you want to think about that as multiplying by -1. So again, in this case, we would get 3 plus 5 inside the parentheses. We have to do that first because P is first in PEMDAS. We get 8, and then we do the multiplication of -1, which is the M in PEMDAS, to get -8 overall. There's a big difference between -8 and 2, and hopefully that can help you see why this sort of like additional point of PEMDAS really, really matters. Again, if we think more macro, maybe the exam is testing your attention to detail or your attention to detail under pressure. We don't need to like go speculate on that. It's enough to know that they're testing you on this basic skill and that there's probably a great deal on the line for you with this. So you might as well just learn it, memorize it, and practice it enough to be confident with it on test day. That's the point of our discussion today. One final time, and sorry if I'm repeating this too much. I just want to really drive this home if you're on the audio feed so that you remember it and that it sticks and that it's available for you when you need it. Anytime you see a negative sign outside the parentheses, think about it as multiplying by -1. Again, This concept is heavily tested, especially with exponents. The GMAT really likes to test this whole inside versus outside parentheses with a negative sign with exponents. For example, let's say we've got -3 inside a set of parentheses, and then outside the set of parentheses, we're taking that to the second power. We're squaring what's in the parentheses. We'll contrast that in a moment to the negative sign being moved outside the parentheses. So set of parentheses, 3 in it, negative sign to the left of the left parenthesis, and then to the second power outside the parentheses on the right. So let's begin with the negative sign inside the parentheses. So this is set of parentheses with -3 inside of it. We're squaring that quantity. If the negative sign is inside the parentheses, then you are squaring -3. That means you are multiplying -3 times -3, which will yield +9. Negative times a negative is positive. But if we contrast that with the negative sign outside the parentheses, and we have set of parentheses with just 3 inside of it, negative sign to the left, and then exponent of 2 up and to the right of the parenthesis on the right, then you want to think about it as multiplying by -1. And if you stick to that and you stick to PEMDAS, then that will remind you you have to do the exponent first. You have to do the exponent before you multiply by -1. So in that case, you would square +3 first. 3 to the second power is 9. And then after that, you would multiply that result by -1 to get -9. I'm just going to quickly repeat that. If we have the parentheses, if we have the negative sign inside the parentheses, we're going to get +9. If we have the negative sign outside the parentheses, it's -9. So that's a big difference. And it's worth memorizing this because you can almost be certain that both of those would be options in the answer choices if that were a GMAT question on test day. Okay, like A would be -9, B would be +9. And they just love to put us in those kinds of situations where you have the opportunity to doubt yourself and doubt the nature of reality and like the space-time continuum. And we don't want to be thinking about that during the GMAT, okay? We want to know, all right, this is a PEMDAS situation. Negative signs inside the parentheses, it's +9. Boom, that's my answer. Next question. Okay. Very, very valuable. And that's why I'm trying to drill it home for you. I promise I'm doing this with the most pure intentions for you to be as successful as possible, as fast as possible, like I hopefully repeat at the beginning of every single one of these episodes. Okay, one last idea that's related to PEMDAS that's worth exploring, which is the idea of distributing. Consider the example of a set of parentheses with 4 plus 5 inside of it. Imagine that set of parentheses with 4 plus 5 inside of it. And then we're multiplying that whole thing times 3. So 3 is outside the parentheses. In this case, of course, you can just use PEMDAS and add 4 plus 5 first and then multiply by 3. And that's generally a good way to go. But sometimes you might want to handle that differently. For example, what if we change it to inside the parentheses is a variable x plus 5, and then outside the parentheses, we're multiplying by 3. We'll talk more about variables soon, but for now, it's just worth saying that we wouldn't be able to add x plus 5 first. Like we just would not be able to do that unless we have a lot more information in the problem. And so we might want to change the way that that expression looks to make it a little bit easier to deal with. And we'll get deep into this when we talk about algebra in the coming weeks. But let's just start with this assumption that x plus 5 can't be added. And so you're like, well, what could I do there? If it's 3 times x plus 5 in the parentheses, am I just stuck with that? And the answer is no. So what you can do is called distributing. And what we do is we distribute the 3 that's outside the parentheses to each term inside the parentheses. It might seem like we're kind of getting around PEMDAS when we're doing that, but we're actually not changing the value of the expression, so it's allowed. It's like a legal loophole in the whole PEMDAS thing. So let's return to the 3 plus 4 times 5 example. And let's say that we're not going to add 4 plus 5 to get 9 and then multiply by 3 to get 27. Let's say we're not going to do that. And we want to distribute instead. So again, distributing means multiplying each term inside the parentheses by the thing that's outside the parentheses. So in this case, we would multiply 4 times 3 first And then we would multiply 5 times 3. And we would keep the little addition sign between those two terms. Now we would have 4 times 3, which is 12, plus 5 times 3, which is 15. And you'll hopefully notice that 12 plus 15 is equal to 27, which is exactly what we would have gotten if we had done the 4 plus 5 first to get 9 and then multiplied that by 3. We get the same value. So that's why that's allowed, because distributing gets us the same result as if we had followed PEMDAS. It's kind of like a valuable workaround, a valuable side path, or like backdoor maybe. Clearly, when it's just numbers and no variables, that's way more steps and way more work. So I definitely don't recommend doing that if you could just like do the math inside the parentheses first. But if you cannot do the math inside the parentheses, like the x plus 5 example, this is going to be a great tool, um, because it's mathematically equivalent and it would give you a little bit more flexibility. So for example, with the x plus 5 example times 3, we could do 3 times x plus 5 times 3. And then depending on the situation, 3x plus 15, which would be the result of that, might just be easier to operate on or deal with or simplify depending on the other aspects of the problem. I don't want to get too deep into algebra here in this particular lesson. That's coming up soon. But for now, just know that distributing, if you see that in some explanations as you're working on these math basics, is totally allowed. And it technically does not violate PEMDAS, even though it kind of looks like it should. But it ends up working out. That's it. That is everything that I recommend knowing about PEMDAS and what's called order of operations on the GMAT. If you would like some practice building up your PEMDAS skills, I definitely recommend using a generative AI tool of choice. That's kind of a mouthful. Generative AI tool of choice. And using a prompt like something like generate 10 problems to help me master PEMDAS on the GMAT, something like that. Making sure the AI knows that you're studying for the GMAT, that you want to master PEMDAS. You can do your own version of that prompt, and you'll typically get fairly good results. You can always ask for more questions. You can ask the AI for harder questions. You can ask for easier questions, and you can ask for explanations as well. Yes, we're still currently, as of today, in this situation where a lot of these Gen AI tools will do some hallucinations. So you might have to check it with a calculator, but it's still a very great, very flexible tool that you can use to upskill on your own for free. And obviously, if you have a provider that's giving you a lot of structure around the basics, then hopefully this podcast is just reinforcing those things, adding on to your existing studies, and hopefully you're having a great experience with your current provider if you do have a more structured plan. But if you don't have a structured plan and you're just looking to get a little bit of practice, I think those Gen AI tools can be great for math basics. I've said this in the past. I'm just going to repeat it. As of today's technology, those Gen AI tools are not very good at simulating real GMAT problems. Like I wouldn't ask it to come up with a actual GMAT problem for me, because that's going to affect your pattern recognition a little bit. So if you want real GMAT problems similar to what you'll see on test day as a data set to train on, then you definitely want to get what's called the official guide for GMAT review from MBA.com. And there's some supplemental guides as well if you need some more practice questions. So that's a great source of actual GMAT questions. Those are real GMAT questions that have appeared on past GMATs. And AI tools are not good at simulating that. And also, just quick tip, AI tools as of today are not good at helping you study plan for the GMAT. They just spit out a bunch of really contrived stuff that's like a summary of a bunch of blog posts from like the last 10 years. And it's not a good or reliable situation. So if that's the plan you've been using, I highly recommend going back to our study plan episodes from 2024, even the study plan episode from like 2019 in the audio feed way back. It is going to be more valuable than trying to get a Gen AI to teach you how to study for the GMAT top to bottom. Okay. But if you're struggling to understand the explanations in the official guide for those questions, or you want a different perspective on official guide questions, kind of like a digital tutor by your side, then Gen AI tools can be really great for that. You can copy, paste the problem text into the AI, and or actually, I am not 100% sure if that's legal on copyright. So if it's not, I retract that previous statement, and please do not do that. I am ignorant, so please, let's just give that caveat. None of this is legal advice. All of this should be done at your own risk. And this is just my personal opinion as a GMAT expert about what I have found to work for raising people's scores. I do not know if that is actually legal, and huge apologies to anyone who holds copyright if that's not legal. Having said that, if you find GMAT-like problems on the internet and you would like an AI to explain it to you, then that can be a valuable way to increase your skills on the GMAT. And I will leave the legal details up to people who are more informed about that than I am. Again, just trying to set you up for success given the resources that are out there. I personally think that when you're entering the GMAT market, it's very overwhelming how many resources there are, and it's extremely difficult as a student to know like what to trust and what's going to be helpful and what you should invest in. If you're not sure about that and you're just getting started and you're looking to pick a paid provider or just a plan forward in general, then I highly recommend our episode that's titled How to Start Your GMAT Studies in 2024, which is updated for the new version of the exam. And that should be about, I don't know, 30 episodes back, something like that from January of this year, 2024 currently. If you'd prefer to get advice from an extremely well-informed human and not a Gen AI tool, then please listen to that episode and or find us at the GMAT Strategy on any current social channels and shoot us a message, and we will do our absolute best to help you out. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our video on how to reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.